Alrighty, hey AP Chemistry. So we got a question from Destiny to try one of the example problems from section 15.6. So I set us up here where we have CO gas plus 2H2 gas in equilibrium with CH3OH gas. They told us that the initial concentration of CO was 0.27 molar, the initial concentration of H2 was 0.49 molar, and then they said later on in equilibrium the concentration of CH3OH was 0.11 molar, and then the question is, what is KEQ? So, as you've read and looked at the procedure, you've developed what's known as an ICE table, and tomorrow in class we're going to do a lot of ICE tables. So I'm going to start setting up our ICE table. I'm going to rewrite this chemical equation, CO gas plus 2H2 gas in equilibrium with CH3OH gas, okay? And I'm gonna set up my ICE table. An ICE table is initial change and equilibrium concentrations. And this should look very familiar because in the very beginning of the semester, I made you do what's known as a BCA table. So this is just like a BCA table, except instead of having an after reaction, we reach equilibrium. So initially, they told us that my initial concentration of CO was 0.27 molar. So I'm going to put that under I. I means initial. So my initial concentration of CO is 0.27 molar. That's going to go right here. They told us that. My initial concentration of H2 was 0.49 molar. So I'm going to put that right here at initial. They told us that. The first row is your initial concentrations. And guess what? If you remember from BCA, I didn't get an initial concentration of my product. I didn't make it yet. So this is 0. Then they told us way later that the equilibrium concentration, that's what E stands for. E stands for equilibrium. The equilibrium concentration of CH3OH is 0.11 molar. So that's going to go right here. And so now we have to solve for KEQ. By the way, in the very end, I'm just going to write my KEQ expression on the side here. KEQ is equal to concentration of my CH3OH, and it has a stoichiometric coefficient of 1, so I don't need to write an exponent, over CO multiplied by H2 squared, right? So you do concentration of products over the concentration of reactants, and my products were just CH3OH, remember this is division, that's equal to KEQ, and my reactants were CO, 1 as a coefficient, so I don't need to do any exponent, and my H2 had a 2 as an exponent, so that's H2 squared. So later on, when I get my equilibrium calculation concentrations, I'm going to plug them into KEQ. All right, so now, how do I solve this? This is kind of like a backwards BCA table. I gave you my after, or I gave you my equilibrium. Now I got to go backwards. So if I got 0.11 molar, that means I must have made 0.11 molar. So I got plus 0.11 molar here. Now I got to use my mole to mole ratios. So if I made 0.11 molar of CH3OH, my mole to mole ratio of CH3OH to H2 is 1 to 2. So whatever I get here, I double that here. For every 1 mole of CH3OH, I have to double how much H2 I either make or I use. It's a 1 to 2 mole ratio. If you don't know how to set that up now, you're going to have to ask me for some extra help. So for every 1 mole of CH3OH, I get 2 moles of this. So for every 0.11, I must have used 0.22 molar of H2. And then, same idea, for every 1 mole of CH3OH, I only needed 1 mole of CO. That's a 1 to 1 mole ratio. So if I made 0.11 molar of CH3OH, I must have used 0.11 molar COH. And so I need to subtract from my reactants. Remember, we use out reactants, so I'm subtracting from there, and then I'm making my product, so I add to there. So now I just set up my subtraction here. 0.27 minus 0.11 equals 0.11. 0.16 molar in the end. And then 0.49 minus 0.22, I should get 0.27 molar at the end. And I have 0.11 molar in the end already. These are my equilibrium concentrations. It told you that this must be my equilibrium concentration of CH3OH. So I use stoichiometric coefficients and stoichiometry to figure out how much of my reactants were used, and whatever was used is how much is left in equilibrium. So now I'm going to plug these concentrations into KEQ. Alright, so if you don't understand how I did this, you didn't understand how to do BCA tables, and you may need to go back and figure out, how did I figure out this change? Because C is change. And for change, I use mole ratios. And these mole ratios were simple, 1 to 2 to 1. Okay? So go back over and replay the video if you need to on how I got these numbers here using mole ratios. Now I'm going to plug these values in. KEQ equals 0.11 molar over 0.16 molar times 0.27 molar squared. And side note, what are the units for equilibrium expressions? They should be unitless. So 0.11 divided by, I'm just going to multiply my denominator. So 0.11 over, so 0.27 squared times 0.16. I get in the denominator 0.011664. So and that's just because I multiplied these two together. And so I do 0.11 divided by 0.011664. 0.11 divided by 0.0011664. Oops, I did too many zeros. And I get KEQ is equal to 9.43. And that's what some of you have showed me. Okay? Now, I may not use this question on your entrance test tomorrow, but it doesn't matter if I start out with product concentrations as long as I know how to use my change here. In this middle here, I'm using mole to mole ratios to figure out how much of my reactants I have at equilibrium. And then I just plug it into KEQ. This is so important to a lot of what we're doing in chapter 15, so please replay this video if you need to, re-ask me some questions, or follow along. Alright, so I'm hoping this was helpful. Good luck studying for this question tomorrow.